can still make it through the game. So very simple kinds of questions is something like, from a game design perspective is how many resources does the player need, so you know how much of each to put in each level of the game. Quickly, we already went through this question. I saw that most of you are actually familiar with role-playing games like Final Fantasy or MMOs like World of Warcraft, so we don't need to ask that again. So I was going to ask, because these are basically basically spreadsheets with a game layer built over them. So many games offer the ability to convert one type of resource to another. Resource management is a big thing, either directly or indirectly. So in shooting games, you typically have health and ammunition, and you can trade off between them. You can conserve ammunition by being willing to lose more of your health, or vice versa. In role-playing games, you've got tons of numbers. You often have health and magic points, and you can cast, for example, a healing spell, which will convert your magic to your health. And so maybe a healing spell costs 50 magic points and restores 250 hit points, and so you know the ratio. And you might have to ask questions like, well, what is the total amount of damage that a character can take before they run out of both hit points and magic points? So any of your students who play games like Final Fantasy or like World of Warcraft will probably be familiar with these kinds of calculations. And they might be surprised to learn that the math that they're learning in your class is exactly what's needed to solve them. So there are still similar stat calculations for dealing damage. Those of you who do play MMOs, massively multiplayer online role-playing games, will probably be familiar with this concept of DPS. It stands for damage per second. And here's how it works. Basically, you have some kind of attack that does damage within a given range, say like 17 to 23 or something. And this attack has a certain speed or refresh rate. So maybe you can only use it once every 0.4 seconds. So you can attack 2.5 times per second. And maybe another attack does more damage, but it's slower. Maybe you does 31 to 39 damage, but you can only use it every 0.6 seconds. And you have to figure out as a player which of these two weapons is better. And what better means in this case is doing more damage per unit time. So you have to multiply all this out and make a numeric comparison. So that's pretty straightforward. And now I do have another question here. How many of you actually have your students use tools like calculators, computer software, MATLAB, Excel, anything like that in your math class? So some teachers like this, some don't. Wow, this is really interesting. When I was in high school, it seemed like a matter of huge debate among math teachers whether to do this or not. Some really liked using the tools because it freed students to think of the concepts. Others felt like, like they really just didn't trust these things. So this is really interesting to me that a lot of you actually use these things, and it's just kind of taken as a given that your students need to know how to use calculators and things. That's great. So if we can close this poll. So the reason I ask is because I'll just say that game designers in particular use Microsoft Excel a lot. Excel is to game design what word processing is to creative writing. Yeah, that's true. We do have a biased sample here, I guess, because we're all online to begin with. So yeah, Excel is really heavily used, and if you're teaching computer tools like calculators or especially Excel, there's another hidden opportunity here if you're talking about DPS calculations, and that is you could give your students something like 10 or 20 of these damage and speed combinations and have them write an Excel formula themselves to do all the min-max calculations for them instead of needing to write it all out by hand. So that's actually a really useful skill for designers, to be able to set up a spreadsheet that will solve a problem for you. So that exercise is more something that students as game players might do. And you might wonder, well, what about game designers? Well, designers are the ones that come up with these numbers and in the first place. And I assure you that as game designers, we do not just pull these numbers out of thin air. Every number in a game is chosen deliberately with a specific goal in mind. And in particular, some weapons aren't just granting better DPS than others, there might be some kind of trade-off to allow them to be better. Like maybe they have a higher cost if you buy them in the store, or they're harder to find in general, so you're not going to find them until later. So another question that's very much a design question here, you might say something like, well, the designers have established that you should be able to improve your DPS by about +1 per hour of play so that you feel like you're making progress. And we have this one weapon that'll increase the DPS of anyone who finds it at that stage in the game by about 2.5. And this is something that we want to be dropped as random loot from a particular monster. And we know from server statistics that some number of these N monsters can be killed in an hour. And so the question is, well, what percentage chance should we choose for this monster to drop this loot in terms of N? And we can go even further than that, because where does N come from? Well, usually in the real world, it comes from server metrics. So we actually have all sorts of login information from our players, seeing what their play patterns are and how many monsters they actually are killing in an hour. So that brings in this whole other math problem of statistical analysis of a large data set in order to find the mean and standard deviation within a given confidence interval. It's probably beyond the scope of a lot of your classes, but still serves as another real-world example of how game designers use math in their day-to-day. And personally, in my classes, I like dropping these little breadcrumbs that are outside the scope of the course anyway, just so that students who are interested in them can kind of follow that on their own time. And as for server stats being public, usually with MMOs, they guard that very, very carefully. However, if you look at Valve software, they make Half-Life, they made Portal, and if you poke around on their website, they do have some metrics from some of their games that are very interesting to look at. You can see they keep track of things like how long it takes people to get through each level, what percentage of players will finish the game and or will stop on a given level. So you can see kind of these decreasing curves as fewer and fewer players complete the later levels in the game. They actually have like visualized heat maps of levels where you can see not only the level layout but also where people have died in that level. So you can see certain hot spots where people are more likely to get themselves killed. A lot of great data visualization going on there for some of their games. So it's a great question. So next, so there's a lot of statistics and metrics and other and probability and all sorts of other things like that can be done for MMOs and RPGs. So the next thing I want to talk about, the next example, something kind of near and dear to my heart, is cost curves. Now the idea is that in a game, some things give the player a benefit of some kind, and they have some kind of cost. And both benefits and costs can be reduced to some kind of numbers, and then the costs and benefits have some kind of numeric relationship between each other that can be displayed on a graph. You find this in a lot of games, but one place where it's maybe the most pure is in what are called collectible card games or trading card games like Magic the Gathering. So I should ask, how many of you have played trading card games before? That would be the next point. For those who have never heard of this before, you can think of this as if you think of old school like baseball cards, like collectible cards, this was kind of these are kind of the the game has cards, they come in packs, they're randomized, and from your collection of cards you can build a deck of cards, and then you play a game with your deck against someone else's deck. Is basically how it works. Yeah, I know very few people who actually still play these things, but plenty of people that got heavily into Magic the Gathering or Yu-Gi-Oh, Pokemon TCG, or any number of other games back in the day. Very very often you ask people, they talk like they're recovering addicts or something. So So here in these kinds of games, and they are still around and going pretty strong, they're just in different channels. Anyway, here individual cards have a resource cost to play them. So like in Magic the Gathering, you'd have a mana cost, for example. And maybe you have some intrinsic drawbacks or limitations that count as an alternate cost of some sort, and then some benefits that the card gives you in the game that would make you want to play it. And this is all math, pure and simple, and here's how it works. So first you have this cost curve. So you have to figure out if it's linear, some relationship between costs and benefits, and you have to figure out if that's linear, if it's quadratic, exponential, maybe even horror of horrors. It's a set of deliberately chosen points that don't conform to a single mathematical equation. Now, you can modify this exercise for pretty much any skill level, but let's say, for example, you want a triangular relationship. This is just, so 1, 3, 6, 10, 15, where you're adding one more each time, that sequence. And that just happens to be expressible through this quadratic equation up here. And you could give that to your students and leave it to them to put it in standard form so they could graph it. This particular function is actually used a lot in games. It's a great way to show this law of diminishing or increasing returns that's not quite as extreme as an exponential or logarithmic relationship. And John, you're absolutely right that Magic the Gathering was created by a math professor. There's also another math professor named Reiner Knizia who has one of the most prolific board game designers in the world. And yes, you're right that Farmville very much is cost and benefits, although in that case a lot of costs and benefits deal with time. So yeah, I mean, without going too much down the rabbit hole of board games, which is a whole other presentation I could give, so at any rate, the thing is, the next thing to do once you have a cost curve is to establish some sort of numeric sets of costs and benefits. So for example, you might say that each colored mana on a card provides a cost of 1, and a colorless provides a cost of 1/2. And if you've never played the game, you might not know what those mean, but you don't really have to. All you need to know is that these concepts have numeric values to them. And you might say each point of power or toughness for a creature is worth a +1 benefit, except that you always start with no power and 1 toughness for free. And let's say that all special abilities like flying and first strike and trample also give +1 benefit each. And even if you don't know what those things are, you can at least know that, you can tie this keyword to a +1 modifier. Now designers need to come up with these numbers initially through some combination of experience and intuition and playtesting. But if you're a junior designer working on content for an established game, this is the kind of thing that you will be given by someone else and expected to follow. So the next thing you need is cards that fall along this curve, or as close to it as possible. So you might say something like, well, we want 2 creatures in the next set that cost 1 white mana, which is colored, and 2 colorless in this set. So that's a cost of 2, which means it should be a benefit of 3. And so there are many questions you might ask about this as a designer, like what's the highest toughness that a creature might have at this cost, or what's the highest power, or what are all the possibilities of power and toughness for a creature of this cost if the creature has a special ability. Or you might say, given these benefits, given this set of benefits and this power and this toughness, how much should the card cost? Or given an existing card with a set of costs and a set of benefits, is this card balanced? Or is it too powerful, or is it too weak? And in order to figure that out, you have to figure out whether it falls on or above or below the cost curve. And these are all pretty basic algebra things, or even pre-algebra, but they are exactly the kinds of things that a game designer has to do off the top of their head, without having to sit down and work out the numbers every single time. So you get better at this with lots of practice. So let's take another example of, and this time with multiple curves that are related to each other. Another case of a triangular curve, this time taken from several role-playing games and video, both tabletop and video games based on them. And this is based on the D20 system that was pioneered by Dungeons & Dragons. So I'm curious, who here is familiar